This is an overview of the finding the middle velocity from the initial and final velocity. This is two groups, two different lab groups will work on the same setup. You're going to have a ramp at a steep angle. We're going to start a cart. At the top, you'll have to play around with where to release the cart. That'll be one of the first things you do. You release it so the cart doesn't, you'll have a ramp down here also. The cart can't run off the end of the ramp. Okay, so, but you don't want it to go like 10 meters and stop. So you want it to go at least halfway down the ramp if you can. So you'll have to play around. Then once you pick a spot to release it from, you'll have to mark that. Then it's really simple. Both groups will use video physics. You will record, one group needs to record from the beginning to the middle, and the second group needs to record from the middle to the end. If you both want to record the whole thing, that's fine, but you might be a little more accurate. Again, you want to exaggerate when you release it. So the key part to being accurate will be finding the exact time that it starts, the exact time that it stops. Finding when it stops can be tricky. But the idea is you release it, you will measure you can measure the distance, you measure the time with video physics. From that, you should now be able to find the average velocity. From that, you should be able to find the final velocity. This is my beginning, this is my final. Group 2 doesn't start until here. So they're trying to find the initial velocity. They're pretending this velocity is the initial velocity. My final velocity is 0 because it's stopped. Again, they measure x and t. They can find the average velocity. And from that, they can compute the initial velocity. The final velocity and the initial velocity should be the same. So we'll find the percentage difference between them. Now, one of our problems is, ideally, we would go straight down the ramp and then we would convert to a flat surface, but we have a little curve here. So you've got to decide, when do I go from going down the ramp to flat? And because when it starts to level off, we're changing the acceleration, which means the formulas we use aren't quite accurate. So I think our best bet is to pick a spot halfway in between, once from where the ramp starts curving to where the ramp flattens out, and let that be your middle point. And then I think the errors will kind of cancel out and we should get reasonable data.